That one, the top one.
The top one?
It's recording.
Now it's recording. Thank you, sir. I forgot.
I'm good. That's fine.
This guy?
Alright, so good morning. Good morning. We're going to go ahead and get started. Just in the interest of time, we'll get started a little earlier. Alright. So just to begin here, we're given this problem. We're going to find an interval. And here I gave you the equation, but how do we know we're using a t interval? Anybody know why? Why does it have to be a t interval? If we've done z intervals, but what's the
Because this isn't probability. We're not doing probability.
Kinda.
Oh, I know.
Percentage or...
It's not asking for a percentage, that's for the mean.
Perfect. We're using a mean, and there's one more detail. It tells us here, during a 2-month period, over 44 days. Over 44 days, we know the average to be 126. Is that a population or a sample average? Sample. It's only over 44 days. So that's our sample. We also know here that in those 44 days, the standard deviation is 15. That is also from the sample. The key thing here is if we have S, that is a sample standard deviation. That tells us to use a t interval. If it was sigma for the population, that would tell you to use a z instead. So just keep that in mind. We have S, so we use a t interval. So now that we have that, we know the mean. We know the mean to be 126. The t star. What would be our degrees of freedom here? What's our sample size?
44 days.
44?
Minus 1.
Degrees of freedom minus 1, 43. But notice that if you wanted to find the degrees of freedom for 43, is that going to be on the packet that we have?
No.
No, it counts by tens and eventually counts by tens up to 100, and then it just goes to 1,000. Yeah.
It's not fair.
Unfortunately, it doesn't have the exact value that we want, but the next closest value is 40. We round down. So I gave you the t up here. That's our critical value. And now we just find our equation here. S was given to us. Square root of our sample size of 44. So this is our interval.
Well, you should do that, but I have 1.684.
Is that what we got? 90%. It's a 90% confidence interval. Is that okay?
Yep.
Okay, just making sure, because I did it kind of fast. But again, that's the idea. The nice thing is the confidence intervals, the critical value, it's really easy to find. And again, just keep in mind that the very last row, those are our z critical values. So you don't really have to do any calculations to get that. You could just rely on the table. If you choose to do calculations, you're being conservative, and that is okay. All right, so the answer that we should get, it's given here. it should be between $122 and about $130. And notice that they chose to continue with the critical value for degrees of freedom of 43. We could have done that. We chose to be a little bit more conservative. So if we are more conservative, will our interval be larger or smaller? Will it be wider or narrower?
Narrower.
Narrower?
Wider.
Wider.
What do you think? Why would it be narrow? Why do you think it would be narrower?
Well, because when you round down.
Okay. So maybe when you round down, that makes sense. What else? What else do we think? Why would we say it's wider?
Actually, I know why it'd be wider.
What do you think?
Because when you round down, you're not, it's not the exact, it's like rounding a little, like if you think of like standard deviation, like this is the middle, instead of going here, you're rounding like a little here, so it's gonna be wider.
Okay. Any other explanations for why it's wider? So if you notice on the t-table, as you go down the t-table, it gets, the degrees of freedom get larger, but the t's get smaller, the critical values get smaller. That's because we're getting a better estimate. So when we round down, our t is bigger, our interval is wider, so it's like we're being more accurate instead of being more precise. So we're dealing with that issue. All right, so at this point, we're gonna go ahead and get started with our activity. So before we actually start doing stuff, we'll talk about what we have here. All right, so the name of our activity is Hershey's Kisses on Confidence Intervals. So we'll be getting some candy in a moment to get us started.
Oh yeah!
So before we get started, here's a little, it's kind of a little math joke. I got instructions from my statistics professor. He was 80% confident that the true location of the restaurant was in this neighborhood. If they're looking for it, what happened? If he's 80% confident, is there a chance that the location of the restaurant is not where they're at?
Yes.
Yes, there's a chance. So what ended up happening is that they were fairly confident they were maybe within the block that they needed to be, but unfortunately, it was outside of that range. And it could be anywhere in that town. So they're lost. All right, so we'll go ahead and get started here. The activity, what we're looking at is we're going to get Hershey's Kisses. With these Hershey's Kisses, what you'll do is, before you eat them, you'll take the Hershey's Kiss. I'll give you a handful. And your goal is for it to land on its base. In other words, it has to land like this. So you're going to flip them like if you were rolling dice. You're going to flip them like you're rolling dice. And your goal is for it to be on its base. If it lands on its side, in other words, that is considered a failure. So to get us started, all right, so just to get us started, what's going to be our population? What's our population?
Population will be however many tribes, right?
Well, population is talking about everything. So would it be just all of us in the class?
All Hershey's.
What do you say, Christian?
All Hershey Kisses on planet Earth.
Perfect, that's fine. All Hershey's Kisses on planet Earth. Are we able to test all Hershey's Kisses on planet Earth? No.
Just Earth.
Okay, all Hershey's Kisses everywhere, I guess. So that's the idea. That's our population. What would be our sample size? Maybe this class, or you can even take it smaller to be just your data to begin with. So as long as you take it to your data, that's okay. And your sample will be begin here. You're flipping them. Don't worry about where it says the results of those in your group. You're working with a partner, so you're working with two people. So however you want to split it up at your table, it's 2 people. I'll give each group 5 Hershey's Kisses, and we'll get started here. So let's just get some stuff passed out. To record your data, use this table here. You're gonna have 10 trials because you're gonna have 5 Hershey's Kisses. Record how many successes you get. Record how many successes you get.
Yay! Okay, so I saw one girl tweet and then it's just like, I know, and then Alexa.
Okay, so how it started was DJ sent it to me and Luis. We were
So what is that one?
yeah, I was like, it's just all changed. I texted the girl. Hey, text me. She's like, oh, no, it's all just. But then, like, like, here right now, I really
No,
Would you like to text someone?
No, me and her look apart. Yeah. No, me and Alex look apart.
What did
No, one of them was, I don't want to be the other
okay, you guys don't like acting on stuff that we
Let me see, Luis, honestly, let me see. Stop, you no, you're
The one that's right is the
Luis, did you just get him done? Let me see. Maybe like 2 days ago. Thank you. Let me see, Luis, let me see. I'm gonna be dead at heart. What are you gonna walk around like that all day? Luis, stop. Luis, seriously, stop.
So like if they land on their base.
Stop. I'm not making funny, I think it's sweet. I think it's just the arch, or like this part. It just looks thicker, it looks thicker right here than or it's just, it looks like it goes down a little bit up. This looks just straight and then down.
You noticed the rubbing on the
No, no.
Okay, I wanna say, oh wait. Where are we right now? Population.
It got big. You have, you'll do 10 trials, in other words, you put this.
It's a sample vibe.
Well, I guess it says to do a, it says 50 to do a 10.
We started and the other to the side.
Alex, we have to do each trial.
So each trial takes like
Yeah, well, each trial is 5, but your entire sample is
We drop them all. So it's drop them all.
none of them.
Count the number that land on their base. 5 times 2 Go. Oh, the land on their base.